All right. Welcome back. I hope you had a great lunch. My name is Emil Kvarnhammar. I know many of you since before. Really happy to be here to talk about security threats and mitigations for iOS developers. I actually thought of renaming the title just a couple of minutes ago because I bet that, well, how many of you are iOS developers? Not that many. So that's what I suspected. I thought of renaming this session to be more like iOS security threats and mitigations for developers. Because this is really useful information for everybody who's doing development. And I bet that many of you have people in your software development organization that does iOS development. And you're probably using iOS devices, so I bet you find at least some of this interesting anyway. And I think it's particularly interesting just because we often ask ourselves, isn't iOS secure? Well, isn't it? What do you think? Do you think someone could hack a fully patched iPhone or iPad today? Yes. Someone read the Wired today or yesterday maybe? We're going to talk a little bit about that. And there's a lot of money in this as well. And I think that it was, well, of course, as any other platform, it takes a while before it's getting more mature and that the most obvious security vulnerabilities are gone. So, but I think that iOS has gotten quite far now. Like issues like this go to fail. This is no longer an issue as long as you have fully patched, of course, or patched to a more recent version. But it's actually not that long ago that it was possible to do man-in-the-middle attacks on TLS and SSL sessions on all iOS devices. That's quite serious. That was completely undetected. Remember Niall's session just before lunch? He talked about as long as an attacker is in the same network. That's really all that was necessary to attack SSL and TLS sessions. So inspecting all encrypted traffic, all secured traffic, like internet banks, like corporate email, things like that. VPN. Another example of attacks against iOS was the WireLurker. WireLurker was really one of the first real malware threats on the iOS platform. And this took an interesting path because they used what's called an enterprise signing certificate to sign the malware, which means that it doesn't mean much to have a mandatory code signing if you could still get signed code to execute if you're a malware author. And I think that the more recent attacks has been very much focused on, maybe you heard about XARA, cross-application resource attacks, and that's more or less the same as what we refer to as masque attacks. This is a group of, or a type of attack where you write an application and deploy an application that mimics a legitimate application out there already. And it can actually not only mimic that application, it can actually replace that application on the device, taking complete control over that sandbox, which means the sandboxing model is totally broken. And So even if you have a kernel-enforced sandboxing model, then if you have other vulnerabilities related to the install procedure of applications or the code signing procedure of applications, then it might still be possible to break that sandboxing model. And there was a recent vulnerability discovered in just a couple of months ago on iOS on the airdrop protocol. This enabled proximate attackers to just install arbitrary applications on a device, even if that device had a passcode. If it's a strong passcode set on the device, you could still, from the idle menu, you could still enable airdrop and make the device accept incoming airdrop transfers. You could actually install applications through airdrop even if the user decides to decline that transfer, which is quite interesting. And related to what I started with in this session, like about platform maturity, we also need to think about how new features are getting added and that the added features introduce new vulnerabilities. And that's exactly what's happened with airdrop. Airdrop hasn't been there forever, right? And the same goes for masque attacks. Like, for instance, nowadays there are possibilities for developers to make extensions to applications. That wasn't possible before. And extensions and plugins are also introducing new ways for attackers to inject code or execute code within the context of another legitimate application. How many of you heard about Xcode Ghost? Not that many. Well, I really hope that if you have colleagues that are developers on iOS or OS X, I hope that they have heard about this, because this is a huge problem, potential huge problem for developers of that platform. They are using Xcode, right, to develop their applications. And this started out in China, and a smart attacker wanted to utilize the fact that many developers in China were experiencing slow download times towards the developer network website at Apple in the US. So when they wanted to download a new version of Xcode, it's like several gigabytes, and it just took too long time. So this attacker started to create a repackaged version of Xcode and place that on a local site in China. And in the internet forums where Chinese developers were complaining about the slow download times, he just pasted the link to, well, use this link instead. I've downloaded Xcode once, and you could download it from here instead. And that's going to be a lot faster. And this spread fast. So all of a sudden, this was a complete new attack vector towards iOS applications. Without having the ability to inject code into existing applications, they instead chose the path to take control over the developer's toolchain and inject code into the applications while they're being built by the application developers. And then that application developer uploads it to the Apple App Store, thinking that, well, this is the code I wrote, of course. And without knowing that there was some extra piece of malware code being injected in the background. This affected like hundreds of applications. We haven't heard much about this here, and that's probably because those applications were on the Chinese region of App Store, most of them. Of course, when Apple noted this, remember, this passed the Apple App Store review, all of these. But when Apple were notified about this issue, of course, they immediately withdrew these applications from the App Store. But this causes another issue, right? All of a sudden, Apple has to contact all the developers behind these applications and tell them, well, you need to supply a new one. And you need to make sure that you do that with a legit version of Xcode, not the version you have running on your machine. And these were extremely popular applications like China Unicom customer service. Well, maybe that was not the most popular, but Angry Bird 2. Imagine how many devices. There are no, at least I haven't found any official numbers of how many devices that were affected of this. But this is a good example of when security is getting more and more restrict in one fashion, then attackers choose different paths to attack the same goal, to achieve the same goal. So if there are no obvious exploits to use to execute within another application's context, then they might choose a path like this. I mentioned Wired, and there was an article posted yesterday about this, that it's nothing new that there's been a $1 million bug bounty for iOS out there for at least 2 months now. But what's new is that there's actually been one that's been paid, at least as 7-digit amount. So, like at least $1 million has been paid for this vulnerability. It's an ability to execute code on a fully patched iPhone or iPad, which means 9.1 right now. Fully patched just by having the user visiting a web link. So that's quite serious, right? And that's a complete jailbreak, taking complete control over that device. The company behind this bug bounty is Sirodium, and they say that this can hack any iPhone or iPad. They say that they are planning to reveal all these details to their customers, not to everyone, to their paying customers. And I think it's particularly interesting with the last part of this, government organizations in need of specific and tailored cybersecurity capabilities. They also said that they won't immediately report this to Apple, which means there probably won't be a patch, at least not now. That's scary. But when we talk about security, if we talk about security from a code review point of view, or if we talk about it from a threat modeling point of view, for instance, we often talk about it from an attacker's point of view. Because if you think about security from an attacker's point of view, you have a totally different mindset. There's no reason to think about it from a defender's point of view. So what does that mean? Well, what's the idea behind attacks in general? It's usually to steal some data. And one way to steal data, not the only way, but one way could be to execute code, which is the ultimate goal. If you're able to execute code, then you can do lots of other stuff as well. You could have those clients that are infected, you could have those execute arbitrary code and participate in a botnet or something. So ideally, you have some way of remotely controlling these through command and control centers or things like that. And you can use these to send out phishing emails and whatever you need those clients for. So we're going to talk about the security mechanisms in iOS to understand how these security mechanisms help us, and then later we're going to look at a few demos how attackers can utilize the vulnerabilities in iOS. So one is the App Store review, and we already seen an example of how that can be circumvented or bypassed. And of course, it's extremely complex to have a bulletproof App Store review, since that would mean to basically reverse engineer all applications being submitted. And that's quite many applications. And you would have to look for malicious behavior and all types of malicious behavior. And that's not as simple as looking at the use of a certain API. That's basically reverse engineering and finding out what every piece of instruction is performing. But still, like someone mentioned earlier today, if we're only protecting against like people who don't have a zero-day exploit, if we're just protecting against like semi-skilled script kiddies, like Andreas mentioned, then it might be sufficient with the App Store review, because the App Store review is still going to like sanitize what's ending up on our devices. At least in a more strict way compared to Google Play, for instance. So another security mechanism is the mandatory code signing, and that, I would say, that saves a lot of headache, because more or less, when we do hack demos on Android devices, more or less all of these demos are possible because of the lack of mandatory code signing on Android. So that's really, I would say that's the most powerful feature, security feature of iOS. So if the code's not signed, if the device is not jailbroken, of course, if the code is not signed, then it's not going to execute unless you find a security vulnerability. And there is one extra unless. Well, another possibility is to have what's called an enterprise code signing certificate. And since a year or two back, that's more or less always being used for jailbreak authors. When they want to have an initial starting point to execute some code on the device, they use an enterprise code signing certificate. And the reason that enterprise code signing certificate could be a problem is that the initial idea behind those is to have in-house distribution of iOS applications and have the ability for enterprises to develop their own applications and distribute those to the users within that company without having those applications passing through an App Store review. So that's sort of like the shortcut to getting code to execute on a device, which means we no longer need to follow these sanitization rules or those best practice rules that Apple has set for the App Store review. Sandboxing. I talked about sandboxing. It's enforced by the platform, and the intended purpose is, of course, to protect the resources for that application so that files read and written by that application shouldn't normally be accessed by other applications. And still, there are breakout vulnerabilities for most versions. I haven't heard about the iOS 9.1 if there is any, but for all versions before that, basically, there has been jailbreak vulnerabilities to break out of the sandbox and start executing code with system privileges. And there is still possibilities, even though you don't have the ability to break the sandboxing model, there are still possibilities to execute within an application's context. And that's the new features I talked about, like application plugins and application extensions. And if you play by the rules, and if you submit applications through the App Store review, then you need to follow the code of conduct, and you need to make sure that you behave exactly the way extensions and plugins are supposed to behave. But if you instead create an application that acts as an extension to an existing application, and if you create that application and sign it with an enterprise certificate, then you have all degrees of freedom, basically. Because no one is going to review that code. There is nowadays mandatory data protection for stored data. It was introduced in iOS 8, but that's still under the assumption that you have a passcode set on the device. Which means that the passcode is going to be part of deriving the encryption key for storing encrypted data in the sandbox. This is the reason why, even if you have physical access to a device, if there is a strong passcode set on that device, then you're still, even if you have physical access and jailbreak that device, you're still not able to extract sensitive information like cached emails, for instance. And as I said, from iOS 8, all the applications are utilizing this by default nowadays. So this is also a good feature, but it's still possible to circumvent through the masque attacks, since, again, that can inject code into, execute code in other applications' sandboxes. And I forgot to mention one attack on this that's been very popular is to go through backups. And that's not only digging into backups that the user has made on their device, from their device to the computer. It's also just utilizing the fact that the device has a backup implementation that you could use as an attacker. If you don't have access to the sandboxing, to the sandbox itself, then you could still, if you have found a device, you could still hook it up to a computer and back up the information from the device, assuming there is no passcode set, of course. So there are ways to disable backup of iOS applications. You can do that per file or per directory. I really recommend doing that if you're storing any sensitive information like key material or unique user tokens or anything like that. If you store that in files, then you should definitely make sure that backup prevention is set for those files. Because there's no reason why this should end up in iCloud or in iTunes on your computer, or even worse, getting migrated to another device, especially not if it's a unique device token, then it should, of course, not end up in another device. And similar functionality exists for keychain functions. If your application wants to store like passwords, user tokens in the keychain, then it's definitely recommended to use all the flags that has suffix this device only. Those items are automatically set non-migratable, so those are not going to follow a backup to another device. And finally, a new feature in iOS 9 is something called App Transport Security. Have you heard about that before? No one? So App Transport Security is really about best practices for TLS. And if you were at the Security Day last year or at Øredev last year, we talked a lot about SSL and TLS and about the importance of not only confidentiality but also authenticity and integrity of messages being transferred through a SSL and TLS channel. And the reason why this is important is that if you don't validate the integrity and authenticity through certificates in an SSL and TLS channel, then it's totally open to man-in-the-middle attacks. So SSLTLS is more or less worthless without authenticity and integrity. So remember that, never bypass certificate validation. And that goes for all programming languages, not only iOS. So App Transport Security, what Apple is trying to improve here is the overall quality of how applications use SSL and TLS. So, and they're trying to enforce this starting iOS 9 by setting a certain set of best practices as enforced, and you can always opt out from these rules. And if you opt out, you have to explicitly set that in a manifest file, declaring what rules that you're circumventing or what rules that you explicitly decided to bypass. So for instance, starting with network traffic in general, it should always be HTTPS, which means SSL or TLS. And you should only use trusted certificates, nothing like self-signed certificates or bypassing certificate validation. And you should always use forward secrecy algorithms, and you should use TLS version 1.2 or later. So, and I think this is a great initiative because this is going to make all the use of iOS applications a lot more secure. And it's going to improve the overall quality of all these applications. Unfortunately, there is an ability to opt out from these rules, and I think people are going to opt out in some scenarios at least. But please, I don't recommend that you do. Think about, in general, in terms of SSL and TLS, always use cert pinning when it's possible. There is no use trusting like 200 of certificate authorities in your system if you're only going to connect to one single party. So if you are backend developers, if you are doing system-to-system communication, then trust only that certificate owner or only that public key for the certificate of the server that you are communicating with. We shouldn't trust like governments all over the world, companies all over the world, because those companies are going to get hacked. And if they get hacked, the hackers will get access to those certificate authorities and have their certificate eventually, at least in some situations. And that will enable man-in-the-middle attacks that you are not going to be able to detect. I forgot to mention that AFNetworking is, since few of you are iOS developers, maybe you haven't heard about that, but AFNetworking is a framework to simplify TLS connections and HTTP traffic in general. And there has been several vulnerabilities. So if you know people developing for iOS, make sure that they are using a more recent version of AFNetworking. There was patches made in April, May this year. I think it was May. Because it used to be totally open to man-in-the-middle attacks if you didn't have the sufficient cert pinning set. And that was definitely not the intention of the developers behind these frameworks. So, time for some demos. And we're going to start with talking about something closely related to the Xcode Ghost. Remember the repackaged version of Xcode. And what I'm going to show is something that could actually utilize the existing version of Xcode on a target system. So we don't need to fool the user into install a malicious version of Xcode. We could actually inject code into an existing installation. And I'm going to show you why this can be a big problem for Apple developers or iOS developers. I'm going to zoom in to my keychain, which is really if you're not OS X users, then Keychain is like a password database. And on all iOS developer machines, there is an item called idmsa.apple.com. This contains the Apple ID of the developer. And not only the Apple ID, but also the password for that user. If we click on that, we can see that this is my account. This is my email address. And in Keychain, you're able to set access control. You can specify what applications that are allowed to read this Keychain item. So in this case, it's only Xcode, because there is no one else that's supposed to be able to read this. No one else should use that keychain entry. But still, if you anyway try to write an application that tries to read that item, which I've done, this is a really simple application. It's just going to call a method print password with an ID of an entry, which is this idmsa.apple.com in our case. And this is the type of keychain item that I would like to print. So the print password function is up here. I'm not going to explain all the details behind this, but this is basically iterating through the keychain items. It's going to find the one with that name and print that to standard output. So if I run this program, nothing happens since I didn't supply any arguments. Excuse me for the lousy user feedback there. You see that I get a warning. Well, that's good, right? Of course, some people would probably click allow on this. And that would be bad, because then the protection wouldn't serve any purpose, really. But at least this is producing a warning saying that this application is actually trying to access just this specific item in the keychain. Would you like to allow that? So if you're careful about your passwords, then you should definitely press deny, and then nothing happens. So that wasn't a very successful attack. But if we do like this instead, we take the same code. The ID is hard-coded here. We take the same source code, but we compile this as a dynamic library instead. A shared library. DLL if you're Windows users. So we compile this as a dynamic library. We inject that dynamic library into Xcode instead. And then we get the password without any warning. Oh, I wasn't supposed to show my real password here for the audience. I have to change that later. And you can see from the printouts here, from the log printouts, that this is really running within the context of the Xcode application. So the reason this works is that the access control on the keychain, that's controlled through code signing, and it's making sure that this Xcode application has the authentic code signing signature, which it still does. It's just that it's also loading an extra dynamic library. And so there's a lack of code signing checks on the dynamic libraries being loaded into Xcode. This is a big issue because this makes it possible without having full access, without having root access to the system. You're able to control exactly what's being produced as the end result from developers, which eventually is going to be uploaded to Apple's App Store without the developers knowing. And I'm going to show a quick example of that. You can see here that there was an exit call. That's the reason why Xcode didn't continue to run. I didn't want to have two Xcode instances running. So I'm going to switch to another example, which is called my Xcode code injector. And this is really simple. And a real attack wouldn't be exactly like this, because this is more focused on illustrating the issue here and making it demo friendly. But what this is going to do, it's going to subscribe to notifications internally in Xcode. And when it receives a notification that a document did change notification, then it's going to inject, if it finds a source code file called appdelegate.m, which is in basically every iOS application, then it's going to inject this test code here. So let's compile that and see if it works. So, and now there is no exit call, so we will get a second instance of Xcode. So I'm going to open testing app, and you'll see by the end there's new code added. And so normally this would, of course, definitely not be added to the source code of the application, because then the developer will eventually notice, hey, Adam, did you add this to the application? I haven't seen this before. So, of course, this would be added at compile time and added to probably to the bitcode stage instead when compiling applications. So we're going to look at some masque attacks as well. Or at least one. I think we only have time for one of them. I want to switch over to my iPhone here. So the masque attack I'm going to try to perform here is to, you see, I have the Skype application installed here. So I'm going to try to replace Skype with my own application. Let's see if that works. And of course, this assumes that you have access to a developer, enterprise developer account, which unfortunately quite many do. So we're going to see if we can replace that. And I need to switch some cables here. We're going to have an iTunes pop up, blah, 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 blah. And I've prepared my own Skype project here. And this is Stefan's iPhone. Where is Stefan? Is it okay if I hack your iPhone? Don't use Skype after this. So we're going to look at app mask attack. And there is something that uniquely identifies an application in iOS application. And that's a bundle identifier. Can you see that in the back? This is now called ts.skype, and this auto-generated from the application project name and from the developer's name. In this case, TS stands for TrueSec. Excuse me. And the bundle identifier for Skype is com.skype.skype. Do you think it's that simple? Yeah, it is. It really is that simple. Let's see if it works. Maybe I shouldn't say too much. I think it's that simple. And running, and we should... Still says running here. I need some more time before I can switch over to the iPhone screen. Still running. Wonder why it takes so long. Let's leave it there and see if we can get back to it. So we looked at injecting code in Xcode, and where we were able to steal the Apple ID developer account, and it was possible to inject code into applications being built by the developer. And it's still running. Now it's starting to happen. So before we go into the summary, I'm going to switch to the iPhone screen. Let's see the magic. Come on. So this is now the super ugly default icon for developers, for developing applications. And if I click on Skype, you'll see that it's no longer the Skype application, it's the masque demo instead. And this means that my application code is now running within that sandbox, and which means that any files that was previously stored by Skype is now accessible from my code instead. And what's even more silly is that if I were to detect that this seems to be, if I start this, well, this doesn't seem to be like the legitimate version of Skype, and I decide to uninstall this from my device. If I decide to uninstall this by doing delete, and then reinstall the original Skype application from the App Store, then that application will still have the same sandbox. So if I have had written new data to the sandbox from my code, then that's going to be used by the Skype application. So, but this has been fixed in iOS 8.1.3, I think. There are more recent masque attacks that were fixed in 8.4 of iOS. So finally, to summarize, since we're soon out of time, there are several great security mechanisms in iOS, but there are also vulnerabilities. Applications can be replaced, app data can be stolen, and attackers can attack your developer machines. And what that means is you should definitely patch your developer stations, you should encrypt your workstations or laptops. You should be extremely careful what tools you're downloading to your developer machines. Sorry for the formatting here. I don't know why it's decided to... All right. I don't know if it's something wrong with this switch. Anyways, maybe we have time for one question. If anyone has a question. Yes? No, not directly for infected applications or for malicious applications, because that's the biggest problem, right? We don't have the same possibility to have like malware scanners and things like that on sandboxed environments like iOS. But there are improvements starting iOS 9 in terms of enterprise signed applications, so that the user will get a warning when trying to install enterprise signed applications. Is this something that you really want to decide to trust? So I would say that that's an improvement, but there are no other direct ways to protect. Except, of course, in general, being cautious about what you're downloading and installing. And also related to if you find out that your iOS or Android device seems to have malware on it, the main issue is that if it's infected at a system level, then there's no good ways of cleaning that device. You could try like making a full factory reset, but that could still leave the malicious code in there, because not all partitions are being cleaned up. All right, I think I have to say thank you, and I hope you enjoyed the presentation, even though not that many are iOS developers. So say hello to your iOS devs for me. Thank you very much.